Hi, welcome to our math. Today I'm doing a series of videos on rational expressions and equations. And right now I'm specifically doing the addition, subtraction, multiplication, division of rationals. Rational means fraction, and a fraction is division that hasn't been divided out. So for these first few problems, that plus sign means you have to do extra steps. And the extra steps specifically are when you do addition and subtraction with a fraction, the denominators have to be the same. And then the addition and subtraction can touch the numerator but not the denominator. For number 5, hands down, what I see students do all the time is they see a k plus 8 here and a k here, and they add 8 to numerator and denominator. But adding 8 does not a equivalent fraction make. If I had 1/2, and if I add 8 to both, I have 9/10. 9/10 is not 1/2. It is darned close to 1, actually. Fractions are division, and the only way you can alter a fraction is through multiplication or division. So you have to multiply to get a common denominator, not add. So I'm going to multiply a k over k to my first fraction. And why I do it to top and bottom, numerator and denominator, is because if I multiply by k over k is really just an interesting version of 1. And to my 5, I'm going to multiply k plus 8 divided by k plus 8. Once again, an interesting version of 1. When you multiply by 1, if we changed these to multiplication, we would have 8 over 16, which is still equivalent to 1/2. As long as you're multiplying by the same thing to numerator and denominator, it's the same as multiplying by 1. So I now have 5 times k plus 8 plus 11k all over k times k plus 8. Notice once I have the common denominator, the addition just is affecting the numerator. 5k plus 40 plus 11k is 16k plus 40 all over k plus 8. Now, I really should factor the numerator to double check, but if I take an 8 out, which is the largest number I can, I have a 2k plus 5. I can visually tell that this fraction won't be reducible any further. If you don't believe it, factor out that 8, double check. Okay, now my next problem is a lot more interesting. It's more interesting because I have to factor first. I don't multiply the trinomial to the first and the binomial to the second. No. Don't do that. Factor. Always start by factoring. So, two numbers that multiply to -60 and add up to 4. Let's see, -60 is, and some of you are like, it's obvious, use the plus 10. And you're right, that's where I should start. But if you haven't factored in a while, we have -1 and 60, -2 and 30, -3 and 20, -4 and 15. Oh, I should have just done the easy because this has a ton of factors. Okay, m minus 6 and m plus 10. So I only need to alter the first fraction. Already both fractions have this m plus 10. All I need to do to get a common denominator is to multiply the first fraction by m minus 6 over m minus 6. As long as I do it to numerator and denominator, I'm all good. The next thing I'm going to do is I'm just going to focus on the numerator for a few seconds. I'm going to do this because I have to do a lot of manipulation, and I kind of did it over here too. Every time I write the fraction, this denominator is done. So I feel like I can just play around with the numerator. The trick is you have to remember to put it back as a fraction at the end. So m times m minus 6 plus m minus 12. And I put it in parentheses. It doesn't need it because of the plus, but if it was a minus, it would need it. And so always do parentheses. It doesn't take any extra time, and it ensures more success. Okay, m squared minus 6m plus m minus 12. Ooh, I should have put the plus m down here. M squared minus 5m minus 12. All right, two numbers that multiply to -12 add up to -5. We have 1 and -12, 2 and -6, 3 and none of those add up to -5, which means this numerator is not actually factorable. Yay, saves us a step. M minus 6, m plus 10. And you have to be confident in your understanding of factoring, because sometimes you get this wild card thrown at you where it isn't actually factorable. You have to just know when to end. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.